normal mass. And those, well, you all did that past paper 1 yesterday. This was that second last question where you had to differentiate a couple of times. So if you just want to copy this one down, if you've got paper to hand, or you might just want to watch, I don't mind either way. So if you're given a displacement equation, I'll tell you what, why don't we just add a +6 on the end? And the question's asking you to do something about velocity. You need to learn that velocity is the rate of change of displacement. So you need to know that velocity is what you get when you differentiate displacement. And then again, you just do it in your head as I'm going along. So how do you differentiate? Step 1, you multiply by the current power. Step 2, you reduce the power by 1. So that's going to be 12x squared plus 6x plus 5. Now, just like the question that came up yesterday, if they're asking you about acceleration, that's what you get when you differentiate velocity. So just like yesterday, you needed to go back and differentiate the velocity one. So that's going to be multiplied by the 2, so that's going to be 24x plus 6. Now, this process of differentiating twice is what we're just going to be looking at today, okay? So we're not looking at it in the context of calculus of displacement, velocity, and acceleration. It's just going to be in a more pure basis. But what we've just done there, we differentiated once to get to velocity, and we differentiated a second time to get acceleration. That is all we are going to be doing today. And some of you, yeah, apologies that I hadn't actually given you much chance to run this off in advance. I accidentally hadn't attached it on Teams. But going forward, let me know if you're not on the Further Maths team. You should be. Some of you who joined late might not be. So just let me know if you're not on the team. Mind you, if you're not on the team, you wouldn't be in this meeting, would you? So that's not great. If you know of somebody who's doing Further Maths who isn't one of those participants, perhaps you could just let me know, and I'll let me know later, and I'll add them. Each week I will schedule a meeting where we would be having the meeting where we will be having the lesson in school. So it's either on the Tuesday or the Wednesday lunchtime. I will do a Dr. Corbett Maths worksheet, which I will attach to the schedule on Teams, so you can run that off in advance. Normally, as you know, I set you 5 questions on Dr. Frost to back it up. This week, you'll be pleased to know I couldn't find any suitable questions on Dr. Frost, so there won't be any questions for this. So this is the title, all right? It's called second derivative. So if we've got y equaling something, and we differentiate it, we get dy dx. And then when we differentiate that again, that's when we get this d2y dx squared. And I don't know why it's written like that. It's just something historical. But all that means is you go and differentiate the differential. So if you get whatever dy dx is, you go and differentiate it again, and just make sure you write it as that. So on the first occasion, the square goes after the d, and the second equation, it goes after the x. And that's all we're going to be practicing here, guys, okay? So I'll just model the first one for you, okay? But it's ever so easy. I expect you'll be able to rattle through these in a few minutes, and then you're free to go, okay? It was quite handy, I think, that the first one we were going to do is quite brief, because just as we're getting to the swing of things. But okay, so if you've got the worksheet in front of you, just work your way through, and I will do the same. So if y equals x squared, x cubed minus 2x squared, and off you go. I think what I'll do it on the board, but I'll go quiet so that I'm not, disturbing your train of thought, and I'm not beating you to it. Okay, so just work your way through that. And obviously shout if you think I make a mistake, because I'm not checking these answers anymore. So we're not actually learning anything new here for Further Maths, just the terminology, I guess, just how you set it out.
Mr. Withers?
Yeah.
Are you going to be setting us an exercise on this, on Further Maths? I mean, on Dr. Frost.
No, I literally just said that, Victor. No, I can't. I won't be because there weren't any suitable questions on Dr. Frost. So on this occasion, Victor, it's only this worksheet. Okay.
Okay.
So I think really what happens is this builds into something bigger in later topics, and those were the questions that were on Dr. Frost. So I think in a way these were almost too easy to be Dr. Frost questions for further maths. All right. So I won't be. If you want, so as I said, you're welcome to unmute now. So if you've got queries, so if you want me to go back to different questions to check your answers, or you think I've gone wrong, just let me know.
So where do we find the sheet?
If you go on to Teams and then go onto the Further Maths team,
Yeah.
you'll see that it's just tagged on below where the meeting is scheduled.
Oh, okay, yeah, okay. Thank you, sir.
Yeah, it was my mistake. I got it ready, or I thought I got it ready a couple of days ago, but I hadn't pressed the little arrow to actually sort of enter it. So it was just sitting there, not actually sent. So it was only became available towards the end of the previous lesson. So if you'd looked in advance, it wouldn't have been there. Going forward, it will be. And as I said, just assume I've got these right. So I'm not checking my answers. So again, if you want me to go back to either question 1 or 2, because you want to check your answer, just say, and I can just quickly flick the screen back.
Mr. Withers,
Yeah.
for question 9, I think there's a line missing.
Okay. I'll yes, you're right. Yes, I think they meant to say, if you look at the screen, they find A. Absolutely right. I thought
Okay.
that. So everybody needs to write down find A for number 9.
Thank you.
Well, thanks for pointing it out.
Mr. Withers,
Yeah,
for question 6,
yeah.
once you've got once you've got the 20x to the power of 4 minus 6x squared, what do you do from there? Because
Well,
you
substitute in x being -1.
Oh, okay. So you just do that. Okay.
Yeah. I've just popped it on the board for a sec. Oh, that's good. Has anyone done the number 9 yet?
No.
Okay. Oh, what we'll do, we'll give it a few minutes, and then I will turn the pages with the answers, I think. And then if you haven't finished, no big deal. You can just play the video back to get the answers when you've done them. So it's 30. Let's just give it a couple of minutes. It doesn't matter if you haven't got all the way through it, but I'm getting hungry now. I wouldn't mind getting something to eat. I'm sure you feel the same. So as I said, in a couple of minutes, we'll go right back and we'll go through it and we'll compare our answers. And if we all agree, we'll assume it's right. If we disagree, we'll just see who's right. Okay, so I'm sure you probably haven't finished yet. If you have done, you've done very well. So let's just go back to the beginning and turn the pages. And you just shout if you disagree with the answer, or if you can just say agree. If you agree, then we'll assume it's right. So I think number 1, everybody okay? We've got 6x minus 4. I think I did that one tonight, so we'll assume that's right. That's a pretty easy one. So number 2, I'll tell you what, it'd be quite good, I think, if people unmute just for this bit, so I can just hear people saying yes if they agree. So can anybody confirm that we got 12x squared for number 2?
Yes.
Yeah.
Thank you. And obviously, if you don't agree, feel free just to ask so you can check where you've gone wrong. Number 3, did people get 18?
Yes.
Yeah.
Yeah. Cool. This is all being taped, so you can come back and have a look at the workings if we're going too quickly for you. Number 4, did people get 44?
Yeah.
Yeah.
Question 5, did we get minus 22?
Yes.
Yeah.
Question 6, did we get 14?
Yes.
7, did we get... Oh no, I haven't finished, have I? I haven't differentiated for a second time. So I just got there in time, so you didn't say no. So d2y dx squared, differentiate for a second time, and you get 40x to the 3 minus 6x squared. Did anybody get that?
Yeah.
Okay, so the difficult bit here is right at the beginning. So put both terms in the numerator over 2x, and then I think it's really helpful if you could get that second term to be minus a half x to the power of 4, but that just makes it quite easy to differentiate. So the 2's on the bottom, so that dividing by 2 is the same as timesing by a half. So I think that step there, if you haven't got, I'm just popping this yellow circle around it, just make sure you're okay with that step there, because that's the trickiest bit of this question. But just to double check, did some people get my same final answer? I think I had some yeses. Somebody just confirm they got 40x cubed minus 6x squared?
Yeah.
Yeah, cool. And 2 to go. Then number 8, people get 16?
Yeah. Yeah.
Cool. And then finally, did anybody get minus 23 over 6?
Yeah.
Cool. So just make sure number 9 that you've gone and realised there's a bit missing from the question. It should say find A. All right, so we've just double differentiated, we've substituted in the minus 23 and the minus a half, and that gives us minus 23 over 6. So that's it. Yes, go on, far away.
Could you, when you've got 6x and then brackets minus a half and then minus 2, that line equaling minus 23?
Yeah.
Could you have added the 2 or?
Have I gone wrong there? Hang on.
I did that.
No, I'm wrong. I'm absolutely wrong. I'm thinking that's been...
Yeah, I did that and got 7.
Yeah, so sorry. Thank you ever so much, Nina. I'm doing terrible maths there. And the embarrassing thing is this is going to be recorded. Oh my God. You absolutely should do. Sorry, Nina. I was thinking that was all being multiplied together. What you must do is add 2 to both sides at that point. Not what I just did. That was rubbish. So adding 2 to both sides, okay, we then get, so we get 6a times minus a half is minus 3a. And that's equaling, once we've added 2 to both sides, minus 20. Obviously, we then divide by the minus 3. We should get a being 7. People agree?
Yes.
Yeah.
Yeah, thank you, Nina.
Subscriber numbers are going to plummet now.
Yeah, so that was, thank you, Nina. I was picturing that minus 2 being in a bracket like it was all being multiplied together, but of course it isn't. So well done, everybody. Short but sweet, but it's all good practice. So go and have some lunch.
Thanks, sir.
Cheers, guys.
Thank you.
Cheers, sir. Bye.
Bye.
Thank you.
Bye.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir. Bye-bye.
Bye.